Uh, good afternoon. Yeah, that assignment right there. So speaking of that assignment right there that some of you did on Thursday when we were finissimo with El Quizzo, what that was all about was it was hopefully going to lead you towards a little bit of an understanding of what we're going to do today, Junior, which is to learn how to solve equations with roots in them, okay? And I am going to give you a money-back guarantee today that you are going to really enjoy what we're doing, okay? Yep. What's that? No, a money-back guarantee. So any money that you have paid me to take this class today, I will refund your money if you're not fully satisfied at the end of the lesson. Okay?
All my tax dollars.
Okay. And how many tax dollars have you paid?
47.
Okay. All right. All right. So here's how it goes. The main thing, I'm not going to write this down, but the main thing just for you to understand about solving radical equations is that you must first get the radical thingy all by itself, okay? There can be no other numbers on whatever side of the equal sign the radical thing is, except for the ones that are under the square root or cube root or fourth root or whatever root thing it is. Okay? So that's always our first goal. And really all you need to do is just pretend that this square root thing is like the variable, and we're just trying to get the variable by itself. So we're starting out with a uber simple one. What do I do to accomplish that goal first? Just plus 1 to both sides. Okay? So our first goal here has been accomplished. The only numbers, symbols, variables, whatever, on the left side of the equation, they're all underneath the square root. There's nothing being multiplied, added, divided, nothing else like that. So now I can square both sides. Yep. So I'm going to square the left and I'm going to square the right. The square root of x plus 5 squared is x plus 5. 4 squared is 2. Oh my goodness, I really worry about the fast pitch team this year. And then finally, you subtract 5 from both sides, and so I get a final answer of x equals 11, okay? I was accused, first period, not once, but twice, by students when they were working on their assignment of not teaching you what you needed to know to do the assignment. So I will try to address that now. If this was a plus instead of a minus, what would you do? Okay, and if there was a number in front that is multiplying this, what would you do to get rid of that? Divide. Okay. Yes, I know. I told them I don't explain to you before class that 5 plus 5 is 10. I assume you know that already. No, they're paying attention. Surprisingly good students, the two students that got mad at me. Okay, if you are someone who is goal-oriented, achievement-oriented, which is most of you are, which is why you're in this class, you can always tell if you get these problems right because you just plug it back in. Okay, good. 11 plus 5 is 16. Square root of 16 is 4. 4 minus 1 is 3. So we are 100% sure that we have the right answer. Okay? All right, let's try another one that is really not any more complicated than the first one. The only difference here that you will notice is it's a cube root instead of a square root. But our goal is the same. The first thing that we need to do is we need to get it so the stuff on the left, the only thing that's there is underneath the cube root. So what did you say, Kylie? Okay, so you have redeemed. No, not really. You haven't. So I know. I'm just funning you. So cube root of x equals 2. This time, instead of squaring both sides to get rid of a square root, I'm going to cube both sides to get rid of a cube root. So the cube and the cube root cancel, so x equals 8. You can plug that in to check to make sure that it works. Cube root of 8 is 2, and 2 plus 2 is 4, so that makes the equation correct. That was unnecessarily cruel, Trevor. All right, so on your own, just real quick, should only take you less than a minute or so. Good to know, will you try these two, and then we'll go through them real quick. For favor. All right, let's see who's the smartest in the land. Haley, what do you do first? Okay, so that gives you square root of x minus 2 equals 2. Okay, then what do I, Levi, what do I do after that? Okay, and if I square both sides, what does that leave me with? Okay, hardest question for the end. Michaela? If x minus 2 equals 4, what does x equal? Solve this for x. 6. Yeah, add 2 to both sides. X equals 6. Okay, everybody get that? Oh, Haley's erasing over there. That's a bad sign. All right, how about the other one? Nayla, what do you do first? Yeah, good. Right off the bat here we can cube both sides, because there's nothing on the left that is interfering with that. So the cube and the cube root cancel, and you get x minus 1 equals 8. So x equals 9, right? All right, how do you guys feel about that? Muy bueno. All right, we're going to raise the level just a little bit here. You know how this goes, right? It's always how it goes. All right, let's try solving a radical equation that looks like this. Okay, so we're going to start with the square root of 3x minus 2 equals x minus 4. What is different and therefore more complicated about this than the other ones? Yes. There are variables on both sides, okay? So, you do, yes. So, our initial goal remains the same. Get the square root stuff all by itself, okay? Which in this case it already is. And then we're going to square both sides. Here's what you need to be careful of. When we square the left-hand side of this, the squared and the square root cancel each other out, and we're left with 3x minus 2. When you square the right-hand side, there is a temptation to write that as x squared minus 16. But that's not correct, because we are squaring the entire right-hand side of the equation, okay? And so I need to figure out what x minus 4 squared is. In other words, I need to figure out what x minus 4 times x minus 4 is, because that's what squared means. Okay? Okay, so to do that, I'm going to FOIL this out. So first times first is x squared. Outside multiplied together is negative 4x. Inside is another negative 4x. And then last times last is positive 16. Good. So if I combine my like terms, then on the right-hand side, I end up with x squared minus 8x plus 16, which Taylor was able to do right off the bat without writing all this out. It would be awesome if you could also do that. The pattern is this thing squared, multiply them together and double it, and then this thing squared. Okay? So it's the first thing squared, these multiplied together and then doubled, and then the last thing squared. Okay? That's how you can do that without writing out all the steps. If you need to write out all the steps, that's totally fine. All I ask is that you do not make the mistake of saying x squared minus 16, okay? All right, now things have changed a little bit because we've got an x squared, not just an x, and so that means our problem-solving strategy is different. I'm not going to get the x's on one side and the numbers on the other. What am I going to do instead?
Get 0.
Right, get it all set equal to 0. Good, so I'm going to subtract 3x from both sides. At the same time, I'm going to add 2 to both sides. So everything over there cancels. And then on the right, I have x squared minus 11x plus 18. Okay? And right, now we can factor that. So that is, what'd you say? Negative 9 and negative 2. Okay? Which means that our answers are x equals 9 and x equals 2. All right. However, one of these things does not work. Jared? Yes, when I get to here, you're absolutely right. I could just use the quadratic formula and I'd get these two answers. One of these doesn't work. Which one and why? It is positive. It's just really, really sloppy equal sign. Why does the 9 not work? Let's check it, shall we? If I plug 9 into here, 3 times 9 is 27. 27 minus 2 is 25. And the square root of 25 is 5. If I plug 9 into here, 9 minus 4 is 5. So both sides work. Okay? So obviously it's the 2 that doesn't work, but the question is why? And the answer is if I plug 2 into here, what do I get? I get negative 2. Can I get a negative as the answer of a square root thingy? No. So if one of these answers, if I plug it into the non-square root part and I get a negative answer, then that answer is not going to work. And we've talked about this before. That's called an extraneous solution. So it's only x equals 9 that works, okay? I feel like somebody before asked me why does that happen. Was that in this class? And I didn't have a good answer, but now I do. Are you ready? Okay. So the original problem that we're trying to solve is when is the square root of, what was it? 3x minus 2? When does the square root of 3x minus 2 equal x minus 4, right? Okay, so you can see from the graph that they intersect at this one point, and so that's why the answer is x equals 9, okay? The reason why we come up with a second answer is because when you square both sides, it turns this square root thing into a parabola, which makes it not okayly have a bottom side also, and so it would end up crossing this line twice. Okay, because it's not what the original graph looks like. Okay, so in the process of solving the equation, we're changing a little bit the shapes of the graphs, which makes new intersection points. I was hoping no one would call me on it. Okay, so when I square the square root of 3x minus 2, I get 3x minus 2, right? And then when I square the x minus 4, that's the one, Mason, thank you for asking, that turns into the parabola. Okay, so this is now what our new system of equations looks like. Here's the 2 that we got that's an extraneous solution. Here's the 9 that we got that's the correct solution. So I kind of fibbed a little bit because I said the square rooted one turns into a parabola, and you were like, no, it does not, because the square and the square root cancel. But the straight line turns into a parabola, the square root turns into a straight line. The idea is the same. This system of equations is slightly different graphically, visually, than the one that we're actually solving. Okay? So that's where that extra solution comes from. All right? All right, Otra Oh, no, this is you. Where was part B? Huh, that's weird. Okay, will you try, you want to try both of them? Yeah. Are you that good? Yes. Yes? Okay, all right. Try both of them, please, on your own, and then we'll go through the answers together. And that's all she wrote today. So when we're done with this, we're good to move on from there. Okay, Maya, what did you do first? And what did you get when you did that? Perfecto. All right, where do we go from there? Landry. Yes, you did, and that is correct. Sorry. Shaylin, what does that factor into? Okay, good, because negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. Taylor, what does that mean the two possible answers are? Our two candidates for solutions? Okay. Why not? Yeah, okay. You know you can't take the square root of stuff and get negative 1 as an answer, so this guy is a loser, and our only answer is x equals 8. Okay? All right, let's try the other one. This one's a little bit trickier. Keenan, what do you do first? What? Perfect. I'm glad that we're having this conversation then. What do you do to start, do you think? Square. Good. So we're going to square both sides. So x plus 2 squared is just x plus 2 squared. What is the square root of x plus 2 squared? Okay, the square root and the square cancel, and you're left with x plus 2. All right, now we have to figure out, Jared, what x plus 2 squared is. What did you get when you FOILed that out? X2 plus 4x. Perfect. X squared plus 4x plus 4 equals x plus 2. So again, you can write x plus 2 times x plus 2 and then do first outside, inside, last. Or you can say this thing squared, multiply them together and double it, this thing squared. Get the same place no matter which path you take. Okay, then Sophie, what do I do from here? Okay, so what does that leave me with over here? X squared plus 3x plus 2 equals 0. And then how do you solve that, Emma? Other Sophie, what are my two answers based on this factoring here? Okay, negative 2 and negative 1. And somewhat surprisingly, they both work. Yeah, if I plug negative 2 into here, I get 0. If I plug it into here, I also get 0. If I plug negative 1 into there, I get 1 and 1. So they both work out. I think they both work out because of the 0 thing. So when you turn that into a parabola, they still touch at the vertex of the parabola. Okay? All right, any questions? That's pretty easy, right? Does anybody want a refund from there? Didn't think so. You have to make an argument.